This is AP Stats Quideo number 4. This specific question is addressing 2 different antibiotics that can be used to treat ear infections in children, and those 2 antibiotics are incorporated into 2 different plans of action for curing this ear infection, and basically comparing their cost and their effectiveness. And essentially the last part of the question is going to ask us which is more effective and which should you use if you were given the opportunity to choose which plan to use for your child. Part A of this question is asking us the probability that this certain child's ear infection will be cured, and basically asking what's the probability for each plan. I have this all on this handy dandy reference sheet here. So I have written out that the probability that plan 1 works, and then all the math that I have. So the probability that plan 1 works is the probability that antibiotic A plus the probability of antibiotic not A times probability of antibiotic B. And when I say probability of antibiotic whatever, this is just referencing the percent of times that it is effective in children, and that's just written right in the question here. It says antibiotic A is known to effectively cure the infection 60% of the time, so I just have that 0.6 there for antibiotic A and that 0.9 to represent the 90% for antibiotic B. So this equation that I have written down is pretty basic. We have it in our notes. It's pretty simple. So basically we have the probability of antibiotic A being effective, which is again in that question of 60%, so we just have it in a decimal, it's easier to work with. 0.6 times the probability of not antibiotic A, so 0.4 just because 0.6 plus 0.4 equals 1. And then the probability of antibiotic B working, which is 0.9, coming from the question which it said it was 90%. And it's also helpful to reference the original problem when you're making this formula, because it says plan 1 is to treat with antibiotic A first, which we have here, and then if it is not effective, then treat with antibiotic B. So then we just have the probability basically of it not working, which was that 0.4% from the other 40% of the time when it doesn't work, then times probability of B, which is the probability of antibiotic B working, which is again 90%. And so that gives us the probability of 0.96 that plan A works. And then essentially the same thing applies to the second one, except we're just going with antibiotic B first and then treating it with antibiotic A if that's not successful, and you end up getting the same exact answer of 0.96. So the probability that either plan is successful is equal at 0.96. And then part B is more on the financial side of things and figuring out which is the better one to use. It says compute the expected cost per child when plan 1 is used for treatment, and then for plan 2. So I have this over here again all worked out on my sheet. So I have all the math for expected cost when using plan 1. So you have the $50, just the flat rate for using antibiotic A, times the 0.6, which is the probability that it will be successful the first time, plus the $130, which is both of these together, times the 0.4 percent chance coming from the 40% chance that antibiotic A will not work originally. So then when you again multiply out, you get 30 plus 52 coming at about $82 for using, that's your expected cost for using plan 1. And then I did this very similar thing for plan 2, except you're starting with antibiotic B. So antibiotic B's flat rate is $80 times the probability that it will be successful the first time, which is 0.9, which is 90%. Plus, again, that $130, which is those two added together, 50 plus 80, which, you will end up using both antibiotics for both treatments. Because if one doesn't work, then you try the other. So you will end up having to pay for both, times the probability that it will not work, which is just 10%. Then again, multiplying out, you get 72 plus 13 coming at about $85 as you're expected. So when you come up with those expected costs, treatment 1 is $3 cheaper because it is at 82 instead of 85. And then part C asks you, which plan would you recommend? And this whole problem basically built up to this moment, because in part A, we calculated that the probability that either plan is successful is equal. So both treatments have an equal chance of being successful, and they're both successful the same amount of times, or it's expected to be that way. So because their effectiveness is already equal across the board, you can look at financial stuff. So because treatment 1 is $3 cheaper, but still as effective as treatment 2, I would definitely go with treatment 1 just because it is $3 cheaper and it has the same probability of being successful just as treatment 2 is. So that's why I would choose treatment 1. And that will be it for Quideo number 4, and have a great day.